And with number 4, I forgot to swipe my board over, so let's go ahead and get reading while I'm erasing. We have, what lump sum do parents need to invest? What lump sum do parents need to deposit into an account earning 10% compounded monthly so that it will grow to $80,000 for their son's college tuition in 18 years? So again, everyone, CERMTN. So do we know how much they want in the end? Yes, they want $80,000. So that's our future value. We want to know how much they need to invest, so that's going to be our R. The rate is 10%, so 0.10. M is the number of compounding periods per year. It's compounded monthly, so 12. T is time in years, 18 years. I is R over M, which is going to be 0.10 over 12. And N is MT, so 12 times 18. And so on my calculator, I'm going to run those two numbers really quick. And 12 times 18 is 216. That's the total number of compounding periods. And so 0.1 divided by 0.10 divided by 12 gives me a repeating decimal. And I need to talk on this point for a moment, everyone. This 3 that keeps going forever, if you choose to use this in Wolfram, you need to carry that decimal out to about 10 places, because that's going to have a huge impact on the remainder of, or the amount of money that's in the account. And so what's best to do in that instance that you get a repeating decimal is to just use the fraction, because the fraction will actually produce a more correct answer than the decimal will. So I will avoid using repeating decimals in these problems because it will throw us off a bit. And what we would need to do is make sure that we use the fraction in that instance. And so again, what's going in Wolfram is S is equal to R times 1 plus I to the power of N. So S is equal to 80, no, we're not depositing $80,000. We are trying to get $80,000. So 80,000 is equal to R, which is what we are looking for, times 1 plus I is going to be 0.10 over 12. To the power of N is going to be 216. So that's what I've got to get into Wolfram, everyone. And so our S, our future value, we want this to be worth $80,000 someday. For our I need 0.1 divided by 12. And then for the N, it's going to be 216. And as you can see, Wolfram doesn't like that we have that capital R in there, so we again just need to replace that capital R with an X, and that will fix everything. And we get this value down here, everyone. The solution is $13,322.90. And so 13,322.90. So to have $80,000 in 18 years, the couple needs to invest $13,322.90 now. So not bad, turning $13,000 or so into $80,000. That's an increase of, gosh, I don't know, like 6 times, something like that. And so again, if the child was to not need the money and leave it in the account until they retired, it would end up being a huge amount of money. Let's play with that and see what that would look like, everyone, just for giggles. So if this child didn't need to use the money and left it in the account for 65 years instead of 18, our T would be 65. Our N would be 12 times 65, which is going to be a bunch. I'm just going to put it in Wolfram like that. And again, I'm just playing around, everyone, to see what would end up happening if this was the case. Um, so if the parents put that 13,003, if, oops, I set this up incorrectly. Let's do this differently. Let's say that the parents left that 13,322.9 in the account for 65 years because the child didn't need it when they turned 18. This would still be the same. And then our n would be 12 times 65. Again, just playing around a little bit, everyone going freestyle. That turns into about $8.6 million. And that's pretty good. So if the child needs the 80,000 bucks when they go to college, great, use it. If they don't, and they leave it invested to the time they retire at age 65, they can expect to have about $8.5 million in that account. Pretty wild.